Alright, got a new project on the bench here. Charlie Brown reached out to me. This old Pride 100A, he asked about it. He wants to go ahead and put this in a mobile for him, and he wants to run it behind a Uniden 510. Or 510 or 520. It's a radio that keys about 3 watts, swings 12 or 15 or so. I told him, this Pride might do what you want to do, but this came from an era of radios that did really low wattage. It's definitely not going to like a 3-watt dead key. So just to make a quick demonstration, even with this amplifier on its lowest setting, we'll just show what you're doing for drive, simulating his Uniden. We got 2 audio, 2 swinging 10. We'll flip the amp on and go over to our 300 watt scale. We're dead keying 100 watts audio, and we're only able to swing maybe up to $110 audio. 1 2 1 2 audio, and we got some issues with the input tune, but that might not be as bad if we stop overdriving this poor little guy. So let's see if we can go ahead and get him an input attenuator put on this, see what kind of options we are, so we can get this set up to work with a more modern radio like he has. Alright, so here's the inside of that amplifier Charlie Brown wants us to go ahead and work on. This amp does need a little bit of love. We have no grommet here for our power wires. That's just asking to get shorted out. And one thing I am looking forward or glad to see is we actually have a variable trimmer capacitor here on the input network. You might have noticed the input needs a little work on this one. So for us to go ahead and decrease the amount of input we are putting into this amplifier without reducing the input drive is we need to adjust the input pad on this amplifier. So I'm going to go ahead and put this aside. There are 2 common types of input pads on, or ways to attenuate your input signal in an amplifier that you'll commonly see. One that I'm going to refer to as the pad. So basically your RF input, so what is coming in from your jack to the input network, they will actually have a resistor in line. So what this resistor does is it's actually going to go ahead and impede the flow of resistance, or impede the flow of RF, going into our input network. So the big thing to think of here, or the easiest way I know to explain it is treat it, the RF, just like if it was water. If we had water flowing in here and we replace this resistor with a straight piece of hose, our input network would get the same exact amount of pressure or water here as we would here. But as we start to go ahead and kink that hose or increase the water's resistance to flow, we're going to get less input here. We're going to get less water over here. So if we have a pad setup where our RF, or our resistor is in line with our input network, as resistance goes up, our input signal goes down. The other type that we also have is what is called a voltage divider, and that is where we actually have a reference to ground. So if we go ahead and we think of this in extremes again with our water example, we go ahead and we get rid of this resistor completely. Our water is able to go ahead and flow from here to our input network freely. But say we were to go ahead and take this resistor and replace it with a piece of hose, and we connect it from here directly to ground. Our RF, instead of actually going to our input network, is actually just going to want to go straight to ground. So this one works slightly backwards. So as resistance to ground goes up, input signal also goes up. So think of this as an extreme. If we basically just got rid of this resistor entirely, all of the RF we put in here would go straight to the input network. And if we just put a short jumper wire, we would just be connected straight to ground. So that is how we identify the type of input network we have and how we need to go ahead and change the value of our resistor. So we need to see if we have a pad or a voltage divider. So if we have a pad and we need to decrease the signal going into the amplifier, we need to increase this increase the value of this resistor. And if we have a voltage divider, we need to actually decrease the value of this resistor. So more RF, instead of going to the input network, goes to ground. The easiest way to identify this is look for the resistor and see if one of the legs of it is connected to ground. So if we actually look here at this amplifier, right here is our high-low switch in the back of it. We have a resistor right here coming from the switch, and it is connected to ground right here. So we know we have a voltage dividing network, but we have two resistors. So this is actually a drawing of our input network pad and how this one actually works on this amplifier. So here we have our voltage input, or excuse me, our RF input, and our input network, and we have our 3-position switch. So in our high position, we are connected to this guy right here, which on the other side of it has nothing attached to it. So if we're attached to nothing here, what do we have? A very high resistance to ground. So none of our RF that is coming in here is going to be sapped away to ground. We are sending all of our power in here to ground, or excuse me, into our input network. When we go ahead and we go to our medium setting, we are going to this guy right here. So when we are connected to medium, you'll notice this resistor here, instead of it having its own path to ground, it's actually attached to our low setting pin as well before it gets to ground. So when we go to medium, we are going through this 20 ohm resistor and this 100 ohm resistor. So now instead of us going through infinite resistance or an extremely high resistance, we are flowing through 120 ohms of resistance total. And when we go to low, we are now bypassing this 20 ohm resistor, and our input signal now only has 100 ohms resistance to ground, taking more of that RF and shunting it to ground. So what my plan for this amplifier is, I'm going to leave this 20 ohm resistor in here, and I'm going to go ahead and try and replace this resistor here, which will change both the low and the medium setting and bring both of them down. So hopefully we have a little bit more flexibility. I was thinking maybe I'll just change one of the, maybe the medium resistor, but, that might not be perfect. So at least here, if we change this resistor, bring the resistance value of this down, I'm going to try a 47 ohm resistor here and see what that does for us input-wise. All right, Charlie Brown, got your pride kind of buttoned up here back on the bench. So made a couple adjustments to it. I went ahead and put ferrite on the input power wires. There was no ferrite. That'll help choke any stray RF trying to get outside of the amplifier. Put that grommet on there, and I've also made the change to your input network. So the change that I made was, I was going to feel really bad about cutting those old vintage Black Beauty resistors out of there and actually making any changes to the amplifier. So what I did was, instead of replacing this resistor here, I took another 5 watt 100 ohm resistor and put it in parallel with our low resistor. So now when we're in low, instead of having 100 ohms here, we have two 100 ohm loads in parallel, giving us a 50 ohm load, or 50 ohms worth of resistance to ground in low and 70 in medium. So in the event that the amplifier ever needs to go back to stock, it's as simple as pulling one resistor back out of it. So I think this is going to work pretty good for you. So before, we were 100 watts swinging swinging to 110. It was kind of out of control. So right now we can actually see what we're doing. Let me kill the mic gain here. We can see we have about a 25 watt dead key. Audio, check, and we're swinging about 80, so that's perfect. I think you're gonna be pretty happy with that. That's a good 4-to-1 ratio. Going to the lowest absolute setting, it just basically takes it to 20 and makes it swing like 65. If we take it back up to the high setting, it's still gonna go ahead and swing dead key. It's 100 watts or whatever. So yeah, that's ready for you to go ahead and pick up.